Okay, as a generator, I've generated media voltage and used it to power the media voltage. Is that clear? I've used it to power the media voltage. So what should I do now? Should I connect this generator to my load or what? Of course not. You shouldn't connect it to your load. So what should you do? Let's think about it. Consider that the outlet in your house is the generator. Do you just plug a phone charger into this outlet, which is the generator, and that's it? Or is it better to connect it to an extension cord? And therefore you plug in one plug that gives you 4 outlets. You start with one for the laptop, one for the phone, one to turn on the TV, and one to turn on a fan. Now, this idea is essentially the concept of the bus bar. So here I have a bus bar, exactly. This bus bar is the metal rod, or what they call your metal strip. This metal strip, engineer, is exactly like an extension cord. I connect it to the generator as if I am the source of electricity, and I start to output more than one line from it. Exactly. So one of these lines is that I output from this generator, from the same bus bar to a transformer. What does this transformer do? I had a voltage of 13.8 kilovolts, which is the standard, or what we have here in the Kingdom of Saudi Arabia. 13.8 from 10 kilovolts. So when I output and take the voltage of 13.8 from 10 kilovolts in the same power station, I have lighting lamps, a fire alarm system, and some control circuits that operate on AC. I need to power a battery charger, which will charge batteries, and supply circuits that will convert it to DC to charge batteries, and supply control and protection circuits. The important thing is that I have something called station services, or what they call auxiliaries, which are fed through what they call auxiliaries. These auxiliaries are one of the feeders or supplies that come out from the generator's bus bar to take the voltage and step it down to be able to supply the circuits. I mentioned to you on it, okay? And then I'll go out, all right? Let's go to my load. He said, wait, before you go to your load, what do you think if we take advantage of the high voltage concept? Now, where is your load? I told you, you have set up the generation station in a remote area, maybe 40, 50 kilometers from here, and you will transfer it until you reach Riyadh, or you have the generation in Al-Aqsa, and you will send it to Dammam, or in Riyadh, and you will send it to Al-Qasim, or you will make an overlap, right? You will say, I am wrong. He said, right. He said, okay, you will transfer this power in the medium. Still, this medium, where should I do it? Well, it's not as high as the low, but the result over this large distance will cause voltage drop and very large losses. So what should I do? Take advantage of the high voltage benefits. The advantages of high voltage are that you will reduce the current, right or wrong? Right. So what will I do? I will use a step-up transformer, also known as a trafo, or referred to as XFMR. Trafo, or they call it XFMR. You can either call it a trafo, which is a common name on sites, or you can call it XFMR, which is like a symbol used to abbreviate the word transformer, XFMR. All right, very good. The step-up transformer in general is a static machine, meaning it's like a fixed equipment or device. All it does is transfer. Look, focus with me. It transfers the power between the primary and the secondary. It takes the power from the primary circuit and transfers it to the secondary circuit. So it doesn't affect the power. It remains fixed in its place, unlike a generator or motor that converts energy from one form to another. No, this transfers the power between the primary and secondary. All right? It will take the power from the primary circuit and give it the mean to the secondary circuit. Very nice, nice. Okay, while it takes this power, I do either a step up to the voltage or a step up to the current, one of the two. So I will do a step up to the voltage to reduce. What? Reduce the pilot and benefit from the advantages of the high voltage. I did a step up. Do a step up for you to high or extra high. It depends on the distance that you will transmit. Usually when you have a long overhead transmission line, like long overhead transmission lines, mashallah, we transfer to the extra high, which is 380 kilos, and the long book, which is more than 150 kilometers. Less than 150 kilometers, you can transfer what is high. Normally, you have no problem. 110, 115, 132, 110, 132. All right. And although sometimes you might also use extra high voltage, which is very nice, the important thing is that I will exit from my bus bar to a transformer. And from that transformer, I will also exit to another bus bar. Now, why do I exit to another bus bar? I'll explain later. All of this is not a power system line, just a single line. I exited from this bus bar to here. And from the moment I stopped at this step-up transformer, meaning the generator with this bus bar and this step-up transformer, I am in the generation stage. What is the generation stage? It's the stage of production. As soon as I take from this step-up transformer to the bus bar, I am in the transmission stage. This transmission stage is responsible for the bulk power movement. Moving this large bulk power that I received from distant places where my power is, in order to do what? To transfer it or move it. Distribute or transmit or transfer it. Okay, this transfer is, of course, three-phase. All our circuits are three-phase, either through an overhead transmission line or through an underground cable or underground feeder. So when do we use an overhead transmission line and when do we use an underground feeder? Well, it depends. Let's see what the advantages and disadvantages are and look at them together. As for the overhead transmission line, the first thing is that it's the easiest among them to set up and maintain. You see, the transmission line is the easiest among them. It is cheap and cheaper to sit up in Minty. All right. And it's easy to suspend over the motorway. What does this mean? It means that for you to install an overhead transmission line, you place 4 concrete bases, install your tower on them, and extend your wires. Everything is in the air. Everything is in front of you, and you can do it easily. Unlike the underground cable where you need to dig the entire distance at a certain depth, fill the whole distance with sand, add some chemicals, place your cable in that distance, and put specific separators at certain intervals. You also need to add bricks, sand, and warning tape following a specific burial method, digging and burying. All of this is, of course, extremely costly for you, especially depending on the geographical places. What does that mean? For example, you might find yourself dealing with hills or areas with rocky features when working with cables. In such cases, things can become very challenging, unlike with underground cables. Another advantage is that it is in the air, which means it is always exposed to cooling, unlike cables buried in the ground that are exposed to high heat levels. So what is the enemy of temperature? Insulation, because the resistance of insulation is inversely proportional to what? To temperature. So as the temperature increases, the insulation resistance decreases to the point where the insulation might do what? Collapse. That's why you'll also find some cables, for example, in Mecca, buried in oil for the purpose of cooling and insulation, right? As I mentioned, it will be cheaper than the underground cable and easy to maintain and repair. What does that mean? Its advantage is maintenance and repair. What does that mean? If there's a fault in your overhead transmission line, you can easily identify it. After determining the location of the fault, for example, through protection relays, you can go to the site and see the fault with your own eyes. If it's not there, you can drive forward or backward to find the issue easily. Also, repairing something in front of you is straightforward. Imagine I tell you that this plug is broken. You can go in and fix it. Now imagine if I tell you that the wire in your conduits is broken. Here there will be a bigger problem that requires breaking things. You need to pull out the entire wire, which requires other things. Right, that's quite good. Well, at the same time, the advantages can also bring disadvantages. What does that mean? Isn't it exposed to the air, which helps reduce its temperature? I said yes. And he told me that it's also exposed to moisture and dust, which can cause many faults and lead to the circuit being disconnected multiple times. Another thing is that it is exposed to the air, so it might be struck by a lightning stroke, which is a lightning strike that hits the line. Of course, this causes damage to the lines and many other things, which is why we use something like a surge arrestor. You will find that birds and low-flying aircraft can also cause problems. When you have a lot of helicopters or aircraft in the area, if there is an operator or an airport nearby, it can cause accidents. Birds or even reptiles can cause a lot of issues for the operator, especially snakes. Additionally, it is restricted by the landscape. So if you then consider the underground cable, let me also show you here. The underground cable, if you are an engineer, you will find that the underground cable tells you what? The underground cable tells you the first thing. It may be difficult when passing through geographical obstructions, such as hills, marshes, and rivers. What does this mean? It means you might be coming with this and find in your area hills, find in your area marshes, which are marshes, and find rivers, which are rivers. Therefore, the overhead transmission cannot easily pass over them. Of course, I'm not talking about seas, I'm talking about rivers. This means a narrow width, and of course, the price is affected when you have loose soil, meaning the ground itself sinks. The soil itself experiences loosening, meaning it's not stable. Therefore, you need special trenches, a specific method for burial, and you use certain materials for burial to be able to bury your cables properly. It can undergo rerouting, meaning its parts can change due to obstacles in front of it, such as pipelines or sewage lines, water lines, etc. In this case, the lengths of the cables will also be longer. Repairing these or fixing them might take days or even weeks. Of course, they are affected by earthquakes. In addition to the fact that as a result of these cables, you find that your cable engineer is essentially a conductor, right? Your cable is a conductor with insulation around it, and it's buried in the ground, which is also considered a conductor. So you have a conductor, insulator, conductor, which can be considered as capacitance. Regarding capacitance, it is epsilon naught times epsilon r, which is permittivity in the area over the distance between the conductors. So the area in cables between the conductor and the ground is just the insulation distance. But in cables, it's small. Unlike the overhead transmission line where it's large, the conductor line is above in the air, and below you have the ground, with a distance between them in meters. However, in cables, the distance between them might not exceed 10 centimeters. Do you understand? So here, you have a small distance, which means the capacitance is large. What does it mean that the capacitance is large? It means the cable is eager to store charges inside it. Or the result, which is the capacitance in what? 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 And it doesn't control the tension. And it doesn't control a bit more overhead transmission, for example. You might find it can increase this power in the receiving end on the other side. For example, it might cause you problems, as I told you many times. Okay, usually let's say that in the case of urban places and in the case of rural places, if you are in rural places, which are rural places, it is preferable to use the overhead transmission line. And if you are in urban places, it is preferable to use the underground cables. All right, great. You went with the overhead transmission line and connected, for example, from Riyadh to, for instance, Dammam, Al-Aqsa, and so on. And you came here to another bus bar. Always, the entry or exit point must be through the connection, which is the bus bar. All right? Very good. This is not what we call it, right? It's called the transmission system. Okay? Transmission system is responsible for the bulk movement of power, or the bulk power movement, which is the movement of the bulk power that came from its source. Then it goes on to find a step-down transformer in front of it, a transformer that reduces the voltage again for it to be used. Okay, here, a transformer reduces the voltage so it can be used. This could be a power transformer or a distribution transformer, depending on its rating, whether it's in kilovolt amperes or megavolt amperes. All right, very good, okay? The important thing is that you started here with the distribution. Here, the distribution is what begins to distribute, meaning it received the bulk power coming from distant places, and then it goes to the demand center. Which are the power demand centers you have? Now, someone might say, well, bring it down to 220 volts. I would say to them, you need 220 volts for your home. You want 220 volts. I am a wealthy man and I have a factory. I need 13.8 kilovolts because I have massive motors. Someone else might say, no, I have a steel factory. I need 33, I need 69 kilovolts. Okay, so what's the idea here? It's not about what you want or what I want. The idea is that there are different loads. Someone might tell me, no, by the way, steel factories don't take 69 because those who need 69 have to take it. I would say, you're right. So the idea, quite simply, folks, is that I have different loads. Of course, these loads are very good, engineer. As long as you are within a certain range, they will tell you that you should be supplied with a loop filter. Like, for example, the houses referred to as residential load. When you move to commercial load, like the towers such as the Kingdom Tower, the Clock Towers, and others, like all the malls, for example. Universities, hospitals, let's say something a bit commercial. So what are we talking about here? Engineers, here we are talking about the fact that it will draw power from me. If I supply these places, you have two problems. One of the problems is that if I give it low voltage, it will draw a very large current because of the air conditioners and other equipment present, like escalators, elevators, and so on. At the same time, it draws a very large current from me. So I must provide it with a very large cable to be able to handle these currents. This is because, of course, what might happen along the way is that the power gets lost, right? The second thing here, as a result of this initial loop, is that it draws this part. The other thing is that the load itself might actually have, like Almarai factories and others, due to their industrial operations here, they need to have slightly larger motors to reduce the power, so they need to get medium-sized motors, medium voltage, depending on the production in general. As a company or a service provider offering different loads, you charge them if you are going to draw more power than a certain megavolt ampere. In this case, first, I will charge you for the watt and the VAR. The second thing also, if you exceed the power with us, you must be provided with medium voltage. You cannot be given low voltage. Of course, each utility in every country has its specific requirements. Okay, great. Now, if you go to industrial, you can treat industrial like commercial, and usually both require medium voltage. All right, great. So these are the three types we have: residential load, commercial load, industrial load, industrial load. That's great. These loads have the same name. We can say there is primary and secondary. Secondary will follow the residential primary, industrial will follow it, and commercial can go with both primary and secondary. That's great. And it can fit with both primary. And what about residential now? All right, but there is something called subtransmission. What does subtransmission mean? Let me explain. Now, I built a power generation station on the road, for example, between Riyadh and Al-Aqsa. You took this electricity and transmitted it via an overhead transmission line into Al-Aqsa. Al-Aqsa has factories and other facilities, and I will start distributing to them. Great. At the same time, Al-Aqsa wants to send one of its lines to Dammam. This means that it received electricity and wants to send it to Dammam from its share. So it will travel again. The electricity will travel again, for example, 100 kilometers to Dammam. Here, 100 kilometers is certainly not feasible to transmit at low voltage. That's why when I step down from extra high voltage, I don't go to medium or low voltage, but rather to high voltage to a slightly lower level to cover the longer distance that I refer to as this short distance. This is what we call a sub-transmission system, meaning a secondary transmission. I had the main transmission and now this is a secondary transmission. So it steps down to a level lower than the main level I was transmitting with. All right, here we learned that I stepped down from extra high voltage to high voltage. And from high voltage, I will step down to medium voltage at 33. And from medium voltage, using a transformer, I will step down to 13.8. From 13.8, I then go to something called an RMU, or ring main unit, which consists of two load break switches. All right, it means fuses or a type of immersed knife switch. And I exit to a circuit breaker. And finally, I exit to a transformer. This transformer converts from 13.8 to 222 volts, which I will supply to our loads. This is like the image you always see next to your house in the neighborhood or on the street. You always see what? You always see the specific part of it, and what else is with it. And what else is with it? All right, from here, I go down this way, not that way, in this direction until I reach here. Whether there are loads of 13 seconds or loads of 30 or loads here on. This is what we call a power system line. So a power system line or electrical power network is the thing that deals with generation, which is the production and the bulk power movement that transfers the bulk power from distant places from the generation to the demand center, which is the demand center where the distribution takes place. Nice. Here, this is called a power system line. So what do? I want to create several power system lines. And when I connect them together, I ultimately have an electrical power network. So what happens is that you will start to see that here, let me bring the annotation here. You will find that you have something here. And this work went to this bus bar. This bus bar might be receiving input from another generator, and here from another generator, and here from another generator. You might find that this piece of the bus bar could be connected to 20 or 30. Yes, 20 or 30. Are all the generators connected to this bus bar? Of course not. And the idea is that here you might find 2 to 3 generators and the rest could be going to different places. So I'm not just going in this direction. And here, upon arrival, for example, let's say I started from Riyadh and went here to Dammam, right? From Dammam, there might be another line coming to me from Al Hufuf, and another line coming from Khafji, and another line coming from various places. These are coming to me from different locations. Okay, and as I go down here, the 33 kV line, for example, I went to the Al-Marai factory or to a factory like steel plants or other industrial areas in Dammam. I went here, not sure where exactly, and then to the 13 and 8 kV lines. The 13 and 8 kV lines connected to something here and something there. So each bus bar starts to have a set of feeders or a set of power system lines that connect with each other. In the end, ultimately, the electrical power network is established. Simply put, essentially, the electrical power network consists of a variety of components.